Welcome to the Introduction to Acoustics for Designers class. Today I'm interviewing an acoustician to see how designers can ensure they create a well-rounded space. During this class, we are going to talk about basic room acoustics, vocabulary. We're going to touch on when to contact an acoustician and acoustic solutions for your space. So let's get started with some introductions. So my name is Carrie Hall. Originally from the Detroit area, I migrated to the west side of Michigan to go to Kendall College of Art and Design for my BA. After that, I started as a designer at a furniture dealer, then facilities design. I took a small pause, started a family, and then serendipitously, I became a manufacturer's rep for APS, selling interior design and acoustic solution products.
So my name is Luke March, and I grew up in a very musical family. We had my mom was a music teacher. One of my brothers is now also a music teacher. Music was a really big and important part of our lives. So then when I went to Kettering University for engineering physics, it was really natural for me to gravitate towards acoustics with the relation to sound and music. I found it really fascinating. So after I graduated, I worked in the automotive field with noise and vibration for a few years with one of the auto manufacturers, and then now I work with Memtech Acoustical, doing acoustical consulting on a pretty broad variety of different projects.
What is acoustics? I'm just going to jump into this because I'm so curious. It's such a broad topic. You can't see it, you can't smell it, taste it. Yeah, it is so disruptive and distracting. What can we do about it? And why is it so important?
Sure, so those are really big sets of questions. So to start off with, when we're talking about acoustics, we're talking about, to give you kind of more of a qualitative understanding of what we're talking about the soundscape of the room. We're talking about how does the sound move and travel in the room? How is your whole sense experience of sound when you walk into a space? So it's often ignored in design because it's not something that you see on the drawings. But it's just as important as other aspects of design because it's just as important sense experience of the space as, say the lighting or visual designs, textures, colors. Just like those play into your experience of a space when you walk in, so does the room acoustics.
Totally. Can you give me more examples about what that might mean?
Sure. So your sense of hearing is always conveying to you information about a space. So a lot of that is processed unconsciously. You're not necessarily aware of the acoustics of the room consciously when you walk in, but your brain is constantly processing this feedback you're getting through your ears. So we're talking, there's the sound of my voice is bouncing around this room, it's bouncing off this wall, some of it's coming back to my ears, and that's telling my brain actually that there is a wall here, that there's a floor here, that there's a ceiling over there, that there's another wall, over that way. And all of this feedback is helping me feel where I'm at in my space very, very tangibly. An example of the opposite of that kind of feedback is in an anechoic chamber. Anechoic chambers, like you can see in the picture here, the anechoic chambers have all the sound absorbing material on all the walls, the ceiling. Some of them actually have a grate floor with sound absorbing material below the floor. So you go in and all the sound is absorbed. There's no feedback, there's no reflections. And it's usually a very disorienting experience to walk into a space like that.
So what determines feedback? And isn't just a little bit of feedback good? Kind of like what you were saying, we need to find our place, sensorial, in the room?
Sure, absolutely. So when you're talking about good acoustics versus bad acoustics, good feedback versus bad feedback, it really depends on what the space is used for and what you're trying to accomplish with the space. So one way you can think about bad acoustics is to think about, are the acoustics or the sound of the room causing discomfort? If they're causing discomfort, if they are interfering with the intended purpose of the room, then that's bad acoustics. So that could be, is there a lot of background noise? You can hear the freeway in the office and it's so loud you can't have a good conversation with your coworkers. That's obviously really bad acoustical design. Or if you need to have a private conversation in a conference room, and even with the doors shut, someone standing outside can hear every word you're saying. That's also bad acoustical design. So there's a lot of things. Is the acoustics in line with the intended purpose? And that's really what determines if it's good acoustics or bad acoustics.
Let me relate to this a little bit better. Can you give me other examples, like what that sounds like?
So one thing you can think about is in terms of light, because designers work with lighting a lot, right? I would assume so.
Absolutely.
So you're thinking about how a room is lit, and if you have too much light, you can get glare. Maybe you have glare off your computer screen. Maybe it's just kind of blinding, giving you a headache. That's no good if you have too much light. If there's not enough light, you can't see what's going on. It's ineffective for your work or whatever the space is intended for. So you can think about the acoustics and the feedback you're getting from the sound in a space similarly to the light. So you want to know, if someone is talking on the other side of the room and calling your name, you want to be able to hear them, right? But if they're having a conversation on the phone in an open office and you're on the other side of the open office trying to work, you don't want to be hearing their phone conversation.
Right. So
too much, and it's like the glare, and it's annoying and distracting. Not enough, and then you can't communicate. Mm-hmm. Does that help make more sense of?
Absolutely.
Okay, all right.
So it sounds like acoustics can be super distracting.
Right, it really can be. And again, kind of like in a visual design, if something is too busy or something is distracting from the focus of the room, and that's equally the case or even more the case with acoustics of how distracting that can be from the point of what the room is supposed to be used for. This was actually shown in a 2012 GSA survey where they looked over time at people's satisfaction with their office environments. And what they found, two of the lowest satisfaction areas in office environments are the noise levels and the speech privacy. And both of those have to do with the acoustic character of the room. So when thinking about good acoustics, one way you can really think about it is like a clean window. You don't notice a window if it's clean, right? You're looking through the window, not at the window. But if it's dirty and smudged, then you notice. And it's the same with acoustics. If the acoustics are good, you usually don't even notice at all because they're working fine. But if they're bad, then you notice. So when you're aiming for good acoustics, you want to aim for transparent acoustics.
So now that we know a little bit more about acoustics, can you help us understand some basic terms to help me speak a little bit more intelligently with my clients?
Sure. So there are lots and lots of acoustical terms. Like any technical field, there's lots of terms, there's lots of jargon. So we're not going to go super in-depth into all the terms out there. If you want to learn more, you can always find a glossary online. I know our website has a glossary of terms that you can look at. But we're going to focus in on two particular ideas and some terms related to those two ideas. So the idea of reverb and the idea of background noise. So reverb is the decay of sound as it reflects from multiple surfaces. So kind of like this illustration here. These lines are representing the sound as it's traveling around the room. It's bouncing off of walls and eventually reaching the person's ear. So the more the sound keeps bouncing around the room, the higher your reverb is.
Can you give us some examples about what reverb might look like?
A great relatable example is an indoor pool. So if you've ever been to an indoor pool, it's loud. It's not just loud because the kids are laughing and shrieking and people are talking, but you have that whole ambience where the whole level is much higher. You have the sound is bouncing off, maybe concrete walls. It's bouncing off the surface of the water and just ricocheting around the room. And it bounces back and forth quite a lot before it dies down. So a room like an indoor pool has a very, very high reverb level. You get something similar in a lot of gymnasiums as well. Kind of the opposite would be if you go into a walk-in closet. So it's close, it's small, cozy. And it's cozy. You have all these so much fabric, right? And the fabric is absorbing the sound in the space. And you don't have anything like the echo that you would have in an indoor pool.
So how does this play into a typical interiors project?
Sure. So one great example of that would be a conference room, right? So here's kind of an example, reference photo of a conference room. You have a lot of conference rooms like this now with big glass walls. You have a lot of reflective surfaces. You have bare drywall, windows, these glass walls, the conference table. A lot of times the floor is also hard, and that lends to a very reverberant conference room. And especially if it's a bigger conference room, that starts to cause issues in being able to easily understand what someone from one side is saying when you're on the other side of the room. It's even worse when you're doing video conferencing or phone conferencing, because now you have all this echo in the room and someone from across the table is trying to talk into the video conference or the phone conference call, and the person on the other end can barely hear what they're saying because it's so echoey, and then everyone in the room is crowding around the little speaker and trying to hear what the person on the other end is saying, and that's also reflecting around the room. It can be a really bad situation. Yeah. And it's a situation that can be avoided if we're aware of the issues and designing for good conference room acoustics up front.
Absolutely.
Another example would be a restaurant. There's a lot of restaurants that are just really noisy and really loud, and a lot of that has to do with the way the room is designed. A lot of hard surfaces, a lot of reflection, and that leads to a very reverberant, echoey restaurant space.
I experience this all the time.
Yeah, just a couple weeks ago, I was at a cafe, and I asked one of the workers what his thoughts were about the acoustics in the space, how he liked the way it sounded, and he said that it was awful. He was a little bit hard of hearing, and he had a very, very difficult time understanding what his customers were saying when he was trying to take their order, especially wearing a mask, right? Because now he can't read their lips, and so usually you have to ask people 2 or 3 times to repeat what they're saying. That would be much less of an issue if they had good acoustics in the room.
Well, that's a perfect client.
Also, a lot of office spaces, a lot of office spaces now are very open workspaces for collaboration. That also means open workspaces for sound to bounce all around the space.
So how can we solve for high reverb or reverberation in general? To
understand how to solve for this, we want to dig in just a little bit deeper into what's going on. So I've mentioned hard surfaces and reflection. So here's 2 other terms that you want to know and be aware of. One is absorption, one is reflection. Reflection is the sound hits a hard surface and it bounces back off. You have a lot of reflective surfaces in a room, you have a high reverb. The other one is absorption, where sound hits more of a soft material and it's absorbed. It hits something like a thick carpet or an acoustical product or like a more plush furniture, and the sound vibrations are absorbed into that material instead of bouncing back out into the room. So you have a lot of absorption that leads to a much lower reverb. And so you can see that in some examples like a hotel lobby. So if you think about the 1950s through like 1970s, Anything that was a high-end hotel is very plush, and you have thick carpets, and you have thick furniture, and maybe you have a lot of thick curtains, and these are all like signs of luxury in that time period. Where in modern design, signs of luxury, everything is hard surfaces. You have marble floors, and the furniture is much less
puffy.
Puffy, yeah, sure. Curtains, big thick curtains are much less of a feature that's used now. People like the roll-up blinds and things like that. So, and lots of glass, right? Lots of glass goes into the modern design too. And all of that aids for a much higher reverb and poor acoustics in these spaces. And this isn't just like hotel lobbies, right? This goes across to restaurants, offices, home design. We see it everywhere.
Lots of resilient surfaces.
Right.
So now that we've talked about reverb and reflection and absorption, so what about sounds like outside that we're not necessarily in control of, like machinery and traffic?
Sure. So that's where we want to go to the other set of terms that we want to look at, which have to do with background noise. So you can think of background noise as sounds that intrude into a space where they're not wanted. So some examples you mentioned, like traffic, that can be a big one. Just the machinery of the building, like the HVAC equipment, can cause a lot of noise issues inside a building. Office equipment, copy machines, things like that. And then even conversations from the next office over. So we see this, like in the illustration here, it's very common where you have offices that are built where the wall dividing the offices does not go all the way to the deck. And then you have, they call it an acoustical ceiling. It doesn't really do a whole lot for the acoustics. So you have this suspended ceiling, and the sound just goes up through that and over this wall that doesn't reach to the deck. And that causes a lot of speech privacy issues. It causes distraction issues as people are trying to work. So those are some common examples of where that happens. Also, as was mentioned before, open offices, you have, and this example in this photo isn't even the most open that these offices get, right? Mm-hmm. So you have all these workspaces, and you have no barrier between you and the person next to you and you and the person across the office. So sound travels very freely across these spaces, which, on the one hand, having an open space can be good for collaboration. It can also be very detrimental to trying to focus on something that you need to work on in depth. So those are kind of some examples of how the background noise plays into the character of the room.
So how would we solve for some of that issue, like say in this open office area?
Right, so we want to dig into a couple other terms. So we want to talk about sound blocking and sound transmission. Okay. So you can kind of see that illustrated in this diagram. You have the barrier there. That could be a wall, it could be a window. So you have the original sound on one side, and then some of that sound is blocked at the barrier. Some of the sound is transmitted through the barrier, and then you experience it on the other side. What we want to do to deal with these sounds is have a better sound barrier. We want to transmit less sound. And you're never going to get to where you transmit no sound, right? That's unless maybe you have a NASA-sized budget and you're building a really expensive lab. But usually you can get a point where it's good enough, where you're transmitting a small enough level of sound that it's not an annoyance and it's not a distraction. So part of dealing with intrusive noises is knowing, okay, what noise level do I need to stay below? And then what noise level am I dealing with out here so that I know what spec to give for my noise barrier.
So we definitely want to avoid these problems in our designs. And I'd like to know, can you predict acoustics? Do we need an acoustician for something like that? Or can we handle some of this on our own?
Sure. So to the first question, yes, you can predict acoustics. Depending on what you're trying to do, it can be easier or more difficult. So depending on what you're trying to do, this might be where you want to consult an acoustician. But in general, it's better, even if you have to consult an acoustician up front, it's better to do that up front than after the fact. Because if you're building this in from the beginning, it's always easier and less expensive to deal with than if you have to go back and retrofit. It's also better for your design, because if you have to go back in and change your original intent just to fix the acoustics, now you're making compromises with what you wanted your design to be originally.
It's an imperative conversation.
Right, absolutely. So predictions can be complicated. For really complicated predictions, computer simulations are used. That's not really used for most spaces that most designers would work with on a regular basis. You would use those maybe for things like classrooms, concert halls, churches, any space that's used for music performance. Then you want to get more in depth with these kind of simulations and predictions. Those can be pretty expensive, so those are usually only used on really big projects. But an acoustician will know what really is necessary for your specific case.
So, well, that helps a lot, but I really like rules of thumb. Mm-hmm. Are there any that you can share with me we could use in our own day-to-day?
Sure. So there are a few good rules of thumb. They're maybe a little bit less precise, but they can still be very, very useful. And they can be useful in having an informed discussion with an acoustician. So one thing we want to look at is, this is our only equation for this whole class. And fortunately, it's not a very complicated one. So what we're looking at here is how many square feet of material you need for a given room volume. And this is an approximation. It's a rule of thumb. It's not a super precise calculation. But the key thing to realize here is that this number can be calculated. You don't have to guess and check. You don't have to guess, well, maybe I need this much acoustic material, and then you build your space, you install it, and then you realize, oh wait, I need more. And then you put in more, and then you realize that's still not enough, and now your design is getting further and further from what you wanted. So you can do this up front so that you know up front, this is what I have to do, this is what I have to deal with, and then you can design for it and plan for it at the beginning. This is the square feet of NRC equals one material, so that basically means, and we'll talk about this more in a minute, that means that this is the square feet of a perfectly absorbent material that you would use. If you're using something that's less than perfectly absorbent, which is any real material, then you need to use more material to make up for that. Beyond that, if you're doing anything for music or performance, you definitely want to consult an acoustician. And if you just aren't sure, you can always call up and get an idea of, hey, is this something that I need more input into? Is this something that I need much help on, or is this something that's more simple? So that's for the reverb side of things. For the sound blocking side, that's where the STC spec comes in. Again, we'll touch on STC a little bit more. And a rule of thumb I would give for that is, if you want excellent privacy, then aim for a STC of 65. Whether that's necessary or not really depends on the situation. But that, if you want something that is excellent, then a spec of 65 is where you want to go.
So we just touched on standards like NRC and STC. So when is this applicable, and how can I use it in the space that I design?
Sure. So let's start with NRC. So NRC stands for the noise reduction coefficient. And that measures how much sound a material absorbs, and that's on a scale of 0, which is completely reflective, to 1, which is completely absorbent. When you're looking at a material for NRC, that is affecting the reverb of the space. Like I said before, some materials are listed as having an NRC of 1 or even more than 1. That's more of an artifact of the way they're measured, because they're counting not just the front surface of the material, but kind of the sides as well. So it looks like you're getting more absorption in a given area than you are. But 1 is kind of the maximum absorption that you can get.
So kind of the sweet spot that I'm seeing is finding a material that is between 0.75 and 1.
Right, so 0.75 to 1 is a good spot for a material that absorbs sound well. And there's a lot of materials out there that are like that. Like this is an example of a sound absorbing foam that is like that. It's used in different lab spaces. Some people use it in recording studios because it has those kind of properties. The other piece you asked about, right, was this STC. So STC is the sound transmission coefficient. That measures how much sound a material or a building construction will block, and that's measured in decibels.
Window, door, wall.
Right, yeah, so maybe a wall construction, maybe a window, maybe like a double or triple pane window, maybe a door. These things all have STC ratings generally, and there's generally some kind of specification that the architect or designer will put in the drawings of this wall is specified, has to meet this STC requirement. Okay. Usually, whatever's given on a data sheet of, this has a STC of 55, in practice, it's usually 10 to 15 decibels less than that, just because of the way that the number is measured and what happens in construction. Because when it's measured in a lab under perfect conditions. When it's constructed, you're dealing with how did the contractor install it? Was it all installed correctly? Do you have different penetrations through the wall, piping, ductwork, electrical outlets? Yeah. So there's a lot that comes into that. So to keep it at a level where you have good performance, you want to aim for a higher STC than you think you need, because in practice it's always lower. So here's another example. This enclosure is used in a manufacturing plant, and these are used a lot for very noisy pieces of equipment to contain the noise around the equipment. And this might have a STC of anywhere from 45 to 75 to contain the really noisy machinery and keep that from damaging workers' hearing.
So when I'm designing a space, I was always told that circular rooms were the most hard to control acoustically. Are there any other shapes of rooms, heights of ceilings, or amount of glass that I have to be particularly concerned about?
So circular rooms are an interesting thing. So what you have in a circular room, or in a room with like a dome, is concave surfaces. And concave surfaces can cause interesting acoustical anomalies, let's say. So they have this effect called whisper gallery. So in this picture here, you can see the whisper gallery. This is in a cathedral. And what happens in a whisper gallery is you're standing in one part of the room and someone else is standing somewhere else, and the sound from your voice is reflecting off all these concave surfaces and kind of skipping along like a stone skipping across a lake, and it reaches them. And even though they're far away, they can hear you whispering. So this was something that happened in the first United States Senate chamber in Washington, D.C. is the shape of the Senate chamber actually caused it to be a whisper gallery, so that if you were in the right spot on one side of the room, you could hear what people were saying on the other side of the room. So there was a senator who people always thought was sleeping at his desk, but actually he was just laying there and listening to what the people in the other party were discussing.
So mischievous.
So the reverse of that is a convex surface. So in this example, you can see the Disney concert hall. And convex surfaces can be very helpful acoustically. That's why you often see these kinds of shapes in a concert hall environment. They take the sound and they, instead of concentrating it to a point where you can hear very specific reflections, they spread it out evenly through the whole room so that people throughout the room all have a good experience with the sound. And it's really cool too, right? Like it has a good design, and it also has these great acoustical elements.
So you're saying I couldn't just do that by myself? I would call you.
Yeah,
definitely.
it probably would be good to actually talk it over with an acoustician. But generally having convex surfaces can be a helpful thing acoustically. So another issue you mentioned, like glass. Really, glass is kind of a subset of having large, smooth, flat surfaces. And large, smooth, flat surfaces can be problematic acoustically. And that's because you have a big surface you have a big surface that sound can just bounce off of. And we talked about that a little bit earlier with the conference room example. Glass itself is kind of a double-edged sword, because glass, if it's planned out acoustically, then glass can be a good sound blocking solution, and that can be helpful in an area like an office, or really any area where you want to have a feeling of openness but you need to block the sound. But glass also adds reflection. So if you're going to have a glass wall, you probably don't want that to be parallel with another large flat wall. You're going to want some kind of acoustical element on whatever other wall is facing that. Having parallel reflective surfaces can cause a lot of problems. So having one wall that has acoustical features is a really good idea in those cases. Even splaying the walls can help somewhat, but usually you would also need some acoustic features.
So when it comes to acoustical products, we hear a lot of things from manufacturers, that they state in their data sheets, or something that we'd read in an issue of an interior design magazine or whatever. And sometimes I feel like I'm reading conflicting information. Mm-hmm. Can you explain a little bit about how, what is myth and what's fact? I really want to know the real deal.
Sure. There are a lot of acoustical myths out there. And I think part of that is because acoustics is complicated, and everybody wants to have something that's a simpler version of it. And anytime you take something complicated and try to make it too simple, there's going to be some kind of misunderstanding. But also maybe some less ethical people would use that to their advantage of saying, hey, I can just slap the label of this is a helpful acoustic product. That'll make designers be more likely to want to buy this product. So there are a lot of products that have an acoustical label on them. That doesn't mean they'll be helpful for your space. So the first thing you want to look at and understand is what is it for? What are you trying to accomplish in your space? Do you need sound blocking to deal with background noise? Do you need sound absorbing to deal with the reverb in the room? Or are you trying to do something with diffusion, like in a musical space? So first of all, you want to define what it is you're trying to accomplish. And then you want to look at the product and say, okay, what is this product accomplishing? Is it rated for absorption? Is it rated for blocking? What is this product supposed to be good for? And then you want to look at what its specifications are. So if you have an NRC of less than around 0.75, it's probably not a very good absorbing material. So there's a lot of acoustical products that are out there that have the label acoustical on them that might have an NRC of less than 0.75, and those might be good design materials, and they might be good, a good visual element for your space. They may not be the most helpful acoustic element for your space.
So maybe layering them, layering different products.
Yeah, or having multiple different products could be a good solution in a space like that. Some products list an NRC based on a very specific installation scenario. So, for example, there's a product I was looking at a couple weeks ago that was listed as having an NRC of 0.95. But when you dug into the details, you realize that was only if that was mounted on furring strips with 2 inches of like a fiberglass insulation behind it. Mm-hmm. And if you didn't dig into those details and thought, oh, I can just mount this directly to the wall, you would not have gotten nearly the acoustic performance that you were looking for. So those are things to be aware of. It's kind of a myth because it's listed as being high, but it's really you want to look at what's the mounting scenario, what is that test based on.
Mm-hmm. It's surprising how much I've ran into that so mm-hmm. far. Yeah.
Right. So definitely something you want to be aware of. Another myth. It's kind of a myth, kind of not a myth, but it has to do with putting batt insulation above a suspended ceiling. I won't say it doesn't help at all, because it does help somewhat. It doesn't help as much as people are usually expecting it to help. In a situation like that, we would normally use a mass-loaded vinyl. There are some other similar products to that are really designed for sound blocking that you can put above a suspended ceiling to help block that noise from going from one office to the next, one room to the next, kind of like we just discussed earlier.
So let's say I need some acoustic products in a space. What do I need to know about product design and or cost?
First of all, there are a lot of options for acoustical products. There are a lot of products that have great design. There are a lot of products that have great acoustical performance. Cost is kind of a function of both of those. You do have some acoustic products with great acoustic performance that are not prohibitively expensive. You have some products that maybe have a stronger design element. The acoustics are maybe not as good, and those can sometimes be much more expensive. So you're kind of looking at the balance of both performance and design and looking at your options and finding what you need. So something you might want to do is look through some options. You can also consult an acoustician to hear about any products that they're familiar with using on a regular basis, and you can kind of get an idea of what kind of design elements do you want, what do you want it to look like, and then what sort of products will help fit into that design or facilitate that design. A lot of acoustic products can be pretty easily customized to fit a specific design look or aesthetic that you're going for.
I think most products have, if they're a reputable manufacturer, they have a lot of really good data sheets.
Mm-hmm.
And, of course, contact the rep for that or,
Right.
Absolutely. It's just digging in for that information.
Mm-hmm. Yeah. And like I said before, if you're looking at the reverb inside the room, if you have an NRC between 0.75 and 1, then that's a good performance marker for, is this going to help with the reflection part of the acoustics inside the room. So a key thing to keep in mind when you're thinking about the aesthetics and the cost and the acoustical performance, and you're trying to balance these three things, is that planning ahead is really what helps you out here. Planning ahead helps you to have a great acoustic design while also having a great visual design. And if you're not sure, if you may be trying to use the equation, but you're not sure if it's quite right or how to balance it out for the material that you're using, definitely you can consult an acoustician and they can help you figure that out. So now we can take a look at maybe some examples of acoustic products used in designs and how those look, and just kind of give you some ideas of, it doesn't have to be really in your face and ugly to sound great.
So this one I'm seeing, this is more of an option that is more of a hidden type of a sound absorber. So,
Right.
So it's like a digitally printed image on fabric, and then
Right.
beneath that, like on the other side, we have some harder working, maybe a melamine sponge type of material or a
Right.
batten. Is that correct?
Yeah, so this is like a custom artwork acoustic panel. You can get it printed on fabric, and then you can have the fabric wrap panel. That would be like, if we wanted this photo here and we wanted this to be an acoustic panel, we could do that, right? We could take that photo, have it printed on a canvas that's designed for being used with an acoustic panel, and then have acoustic panel behind here to help with the reverb in this room. So
Such a good idea.
yeah, so this photo we're looking at here is a pretty similar example to that. This room I think is more of a studio, but you can kind of see how they've worked these
Fabric
wrapped panels into that visual design. This is something where that's really worked into the visual design of the space, right? You could walk in there, and if you weren't aware that this was for acoustics, you might just think, hey, that's a kind of a cool artistic visual design, right? And yet this is dealing with, they have a large flat surface, and so they need to deal with that acoustically. And so that's a way that they're dealing with that acoustically in a very
artistic way.
Yeah, very artistic
I would
way.
even say the chairs are even helping with the upholstery and all the batten
Right,
there.
absolutely, absolutely.
Fabric wrap panels. It's beautiful.
So this is an example of some panels that are again, they come in these geometric shapes, and then they're just applied to, again, a large flat surface to help control the acoustics. And it blends into the visual design. You're using color and shape, and you can kind of see that the floor has a similar geometric design with the wall, and it's all tied together, and it's also dealing with the acoustics.
This product is like a PET material, cut in a really ingenious shape and mounted off the wall, and also like works within the space, kind of resonates with some of the other design elements in the floor. As you see, I think this is a really good application.
So this is an interesting product. Unlike a lot of the other products to control the acoustics, this isn't a soft material. It's not like a fiberglass or a melamine or a PET. This is actually a perforated wood product. And it works on slightly different principles, but it does the same thing of providing some absorption to the space. And the neat thing about perforated wood products is if you have a space where you want to have wood paneling and you also need to control the acoustics, you can combine those together with some of these wood style products.
And it looks great.
Yeah, it's a really good look. This is a really interesting one because this is an example of having a sort of semi-transparent surface that is providing some sound absorption. So again, this has little micro perforations in it as a transparent surface. And these micro perforations, just like with the wood product, are helping to provide some sound absorption.
So the noise actually hits the panel, the surface, but the perforation allows the sound to transfer through and kind of get held back there. So is that kind of the idea of these panels?
It's a bit more complicated than that.
Okay.
It actually, most of the products that are like this with the micro perforations kind of work like when you blow across a bottle and make it whistle. It has like this tone to it that has this whistle. And when you have a structure like that bottle, it's kind of hard to explain briefly and non-technically, but that kind of structure can also absorb sound. So when you have micro perforations, it's like you have thousands of little sound absorbing bottles built into one big panel.
Okay.
So now we're looking at some ceiling features.
This is so spicy. So this is a material, it's PET, right? So it'd be absorbing. This image is just so wonderful. So those are pretty large.
Right.
And it doesn't look like they're covering the entire ceiling. Is the design something like that would be
it kind
helpful?
of depends on what else is going on in the space. Like, certainly it's helpful. Always better to have something there rather than nothing there, right? If you had just that big reflective ceiling, especially because it's concave, that could cause some issues in this space. Whether it's sufficient really depends on what else is going on in the room. Do you have carpet or hard floor? Do you have other acoustic control on the walls? How soft are the chairs? Those things all can play into it. But this is a great way to add a lot of acoustic control in large size panels while maintaining a great visual design.
Absolutely. Again, this is just a great product for having that design element as well as being a hardworking horse in your environment.
Right.
PET is so wonderful.
Yeah, so in this example, you actually have quite a bit more material, per area of the ceiling than in the last example, and you can see why that was done, because you have a hard floor, you have a lot of glass, you have these reflective countertops, even the furniture is very reflective. So the only place left, with all these other hard surfaces, the only place left to put that absorption into the room is in the ceiling. So you have these geometric patterns of the PET material to provide a lot of surface area of material to help absorb that reverb.
Well, that's fun.
Yeah, this is an interesting one. This is a custom cut melamine foam. I believe this is actually the logo of the company where it's installed. Their logo is something like this shape. So they had this custom cut, custom painted to match with the look that they wanted for their branding.
Yeah. It's great. So simple, but yet so effective. Still, the melamine foam?
Right, so these are melamine foam panels. Again, kind of an interesting ceiling feature, tying the colors together between the chairs and the baffles up top, but providing that level of acoustic control that's needed for a conference room like this.
All of these have seemed to be really easily to install too. They look easy to install.
Right.
Anyway.
Generally, anything to control reverb is pretty easy to install. If you're doing sound blocking, that can be a bit more difficult because you're talking structural changes. But if you're controlling the reverb of the space, most products for that are pretty easy. So more ceiling features, these cylindrical sound absorbing baffles, these are also a melamine foam.
That is PET as well. And this restaurant would have a lot of issues acoustically. So I see
Right.
that to be necessary, but also so aesthetically pleasing.
Yeah, because here you still have the high ceilings, right? You still kind of have that open look, you have the hard surfaces, you have the big windows. And by having a grid like that, you're not dropping the ceiling down to where it becomes too close and too, claustrophobic or anything. You're adding this acoustic control, but you can still see through it, and so you still have this open space.
I think the openness too would allow for well enough fire suppression to come through and not to be a worry.
Yeah, certainly that's something you always want to make sure that you're following the fire codes, and sometimes you may have to run the sprinkler head a bit lower than you originally thought maybe you had to, but those are all things that are fairly easy to adjust, especially if you're planning up front.
Absolutely. So imperative. Oh, this is simple and fun.
Yeah.
Triangles.
Yeah, so this is a pretty neat one because this is that kind of open industrial ceiling that you see in a lot of offices, and this is a great way to add some acoustic control to that.
So now I see this perforated wall panel or wood panel that would be on the wall in our earlier example, and now it's on the ceiling.
Right.
I really like that look.
Again, doing the same thing, adding that absorption, but from a different angle than, say, the foam or the PET.
And also it's convexed. So
Right.
it's allowing sound to disperse.
Right. So the sound that's not
reverberation.
absorbed through there is re-radiated and spread out more evenly.
See
through
how
the
much
space.
I've learned so far?
Yeah, you're doing great.
So I think we've covered a lot today. What would I do if I'm not sure how to proceed, or if it's just too technical for my rules of thumb?
So definitely, you can consult an acoustician. I know we would be happy to talk with any designer about their projects and help them figure out quantities of materials or what sort of things would work well in their space. That's something that we do on a pretty regular basis, and would be happy to help anyone who needs further information or help on that.
Well, thank you so much for talking with me today about this, Luke. And thank you for attending our Introduction to Acoustics for Designers video. And don't forget to complete and submit your assessment for your full CEU credit.